Hi, I'm Joel Reardon, a Project Development Manager at SciDev. I've been managing the Narromine project now for about 3 years. This plant was mobilised back in 2019 due to a critical water shortage in town, in the local council area. So what we're doing is we're taking groundwater from these two deep bores and we're pumping them directly into that ISO reactor behind me. That's a 24,000 litre stainless steel ISO tank that's been converted. What we're doing there is we're dosing ozone gas through a Venturi adductor on a recirculation line. So it's quite a simple system. We've got a recirc pump at the back end of that ISO reactor and ozone gas is injected into that line as it recirculates. It's a continuous process. We're treating at 35 litres a second. From that ISO reactor, we pass through to a series of filter vessels, which I'll take you to shortly. You also see there's a hydrocyclone. After we had mobilised and constructed the plant, we were finding that there was an increased amount of abrasive solids in the feed. So that was a later addition to the plant, and basically we're using centrifugal force to remove abrasive solids, sands, from the feed stream. And all of those sands collect in the bottom basin and are pumped through to the sludge dewatering process. On my right here, we've got a typical conventional lamellar plate clarifier. One of the beauties of this plant is we contain all of the waste products in the plant. So we're not pumping any sludge or any waste product over into adjacent dams. We are dewatering any sludge that's generated, we're dewatering on site. So it's quite a conventional system. We're just sending sludge from the filter bank over there on my left into a backwash waste tank, and then we transfer over this lamellar plate clarifier. The underflow passes into a containerised filter press, and the overflow flows back to the head of the works for retreatment. So over here we have the filter bank, and water that has been dosed with ozone in the ozone reactor is sent through the filter bank at a high flow, 35 litres a second. The filter bank's fitted out with actuated valves, which means I don't have to be on site monitoring and maintaining the plant on a continuous basis. And a lot of the monitoring work can be done from the office in Sydney, which is great because Narromine is quite an isolated area and it's beneficial to minimise labour cost and minimise risk of personnel on site handling chemicals and the like. So the goal of this plant is to remove metals, particularly iron and manganese, from the feed. So once we've dosed the ozone gas in the reactor, we precipitate iron and manganese, and then those precipitates are captured and filtered out in the filter bank. There is one final step, which is around here. We found after the initial construction that we weren't quite achieving our discharge criteria. So this was a later addition, basically just an ISO reactor again, but we call this a direct filtration unit. It's filled with a granular activated carbon for final polishing. After that, the water is consolidated in a discharge tank and sent to town. So with this system, we can treat roughly 2.5 megalitres a day. We've been able to achieve slightly higher than that in periods of peak flow or peak requirement, but typically 2.5 megalitres a day. This here is the MCC PLC, the main control board, and what I'm looking at is the human-machine interface, or the HMI. So using the HMI, I'm able to monitor all the process parameters for the plant 24/7 from Sydney or from any office all over the world. Behind me, we've got a rotary screw compressor, an ozone generator, and an air receiver. So what we're doing is we're compressing air, we're drying it, and we're sending through the ozone generator to generate ozone gas. The ozone gas is then used to, as an oxidant to oxidize in the ISO reactor for precipitation of iron and manganese. So again, all built in a refrigerated shipping container, mainly due to the ambient temperatures outside, and we haven't had any issues here in terms of critical repairs or maintenance. Everything's running a dream.